Chapter 2 continues on, starting to talk about slopes. The first section, 2.3, is technically all about linear functions and slopes, and then 2.4 expands the idea of slopes to other types of functions. We're doing it all together because it's all about slope. My friends who've taken AP Pre-Cal before, you're going to see some things that you have seen all last year, and you probably got tired of me talking about, but that's okay. Let's start off with the Algebra 1 definition of the slope of a line. The slope of a line through distinct points, x1, y1, and x2, y2, is represented by the letter m, first of all, which, fun fact, that you use the letter m for slope because it is the first letter of the French verb monter, meaning to rise or to ascend. So we are talking about how much we're going up or going down per unit change. But the slope is just the change in the y's over the change in the x's, aka the vertical change over the horizontal change, aka the rise over the run, aka the formula y2 minus y1 over x2 minus x1. And in fact, I actually want to change the way we read this. A lot of times you saw rise over run, but I'd actually rather us call this rise over right, because every time you're doing a slope, we're reading the graph the normal direction, which is to the right. So how much do we go up or down? Go to the right. How much do we go up or down? Go to the right. That is going to be our slope. It works both left and right directions. I hear you, but let's consider this to the right. Does this look familiar to us, slope? Yeah. This formula? I think on the first day of school I even asked you to do slope questions, so it should. So let's just make sure we know how to use it. We're going to find the slope of the line passing through each pair of points. This first one I'm going to show the work that you've probably shown for forever, which is labeling x1, y1, x2, y2. Love it. I don't necessarily need to see the labeling from here on out, but because these are our notes, we want to make sure we're all on the same page. Let's label. So if we're finding the slope is going to be the formula y2 minus y1 over x2 minus x1. I know I put double negatives right there. I'm doing it on purpose. Because when you look back at your notes, you're going to want to be like, why did these things turn into plus signs? But because we have minus a minus, and again, I'm showing a little bit more work on this example than I will before, those change to plus signs. So we're really doing 4 plus 1 on top and negative 2 plus 3 on the bottom. Well, easy peasy, 4 plus 1 is 5, negative 2 plus 3 is 1, which means the slope of this function is 5. Rise 5, run 1. Rise 5, go to the right 1. So let's do this again on the next problem. Here's the amount of work I want to see on these kinds of problems. Don't need to see the labeling, but you can label if you want. When we go to find the slope between these 2 points, I'm automatically going to be able to do a lot of the arithmetic in my head. This is the second y minus the first y, and the second x minus the first x. We can combine that all into one step as long as you're making sure you do those steps correctly. If you need to show a couple intermediate steps, that's fine. Negative 2 minus 4 is negative 6. 2 plus 3 is 5, so my slope is negative 6 over 5. Feel okay? Huge concept in Algebra 1 is slope. So you're describing the incline of the line or the slope of the line. We always start with that because once we know the slope of a line, we can use a formula that we've derived from this slope formula called point slope form of an equation of a non-vertical line, aka a line, right? We just need to know 2 things. We need to know the slope and we need to know any point on that line, which is why it's called point slope. The formula is y minus y1 equal to m times x minus x1. Notice the m here is the slope, so you will be plugging in a slope to this equation. If the question asks you to write an equation or write a point slope equation, you're literally just dropping the things where they belong in the equation. But it may go on, like the next example, example 2, it may go a little bit further and ask you to solve the equation for y. So we do have a couple steps here. But if we look at this question, it says write an equation in point slope form for the line with a slope of 4, we need that number, that passes through the point negative 1 comma 3. Here's our point. We have a slope, we have a point. We take the blue formula and we fill it in. This is going to be y minus y1, which is 3, equal to m times x minus x1. And again, minus and negative changes that. I wrote a 3. Minus and negative changes that to positive. If you need to show that work, you can. This is point slope. If it asks for an equation or asks for point slope, we're good. We're done. However, like I said, this one goes on to ask you to solve for y, which means we want to get this y variable by itself. We're going to do two things at one time to save paper. We're going to distribute the 4. We're also going to pick up and move the 3 to the other side. If this minus 3 is on the left, when I write it on the right side, what do I write down? Plus 3. So now I have everything on one side and the y by itself. All we need to do is combine like terms. This is 4x plus 7. And so we have an equation of a line in point slope form, and we have an equation of a line that's solved for y. Let's try one more, because this time the question, it backs up a little bit and makes you work a little harder. It says, write an equation in point slope form for the line passing through the points 4, negative 3 and negative 2, 6, and then solve the equation for y. So my question for you is, if we were writing point slope form, we need a point, we need a slope. Do we have a point?
Yes.
Do we have a slope?
No.
Ah, we have to start there. Good thing we already know the slope of a line formula, and so we can find that as a little sidebar. So over here on the side, we're going to find the slope of the line that passes through those 2 points. The second y is 6, the first y is negative 3. The second y is negative 2, the first y is 4. 6 plus 3 is 9, negative 2 minus 4 is negative 6, and that fraction can be reduced to negative 3 over 2. Once I get my slope, we now have everything we need for point slope, because I have a point and I have a slope. We plug it in. This would be y minus y1. Now, it doesn't matter which version, which point you use, unless the question specifically says use the point. I still like to use x1 and y1 as the first coordinate pair that I used in the slope, just for like labeling aspects. You can do whatever you want. This is going to be y minus y1 equal to m times x minus x1. And I guess I wrote that slope in red on the other problem, so I'll do it here. Does everyone see where I'm getting these numbers from? Here's the slope, goes where the slope goes. Here's the y1, goes where the y1 goes. Here's the x1, goes where the x1 goes. Now this is point slope, so theoretically I've answered part of this question because it asked me to write it in point slope. Now it goes on and asks me to solve the equation for y. So we do two things at once. We're going to distribute the negative 3 over 2. Negative 3 over 2 times x is negative 3 over 2x. And negative 3 over 2 times negative 4, here's the trick. Fractions are just top times top, bottom times bottom. So what's negative 3 times negative 4? 12. What's 2 times 1? So 12 divided by 2? 6. Look, you just did fractions in your head. Ta-da! What was the other thing I'm doing on this one step? Moving the 3 by subtracting it from both sides. Fabulous. Now the y is by itself, and I just have to simplify everything down. This is going to be y equal to negative 3 over 2x plus 3. So here's my second form of the equation that's solved for y. We've done both things this problem asks for. So what we've learned so far is the slope formula. Using point slope form given the correct information, or using point slope form when you have to find the slope yourself. No big deal. Questions, comments, concerns? Yes?
Where do you get 4x minus 4?
Say that again. What did I do here?
Yes.
I distributed. So I did negative 3 over 2 times x, which is negative. Yeah.
How did you pull x minus 4 from the equation?
Oh, great question. Okay, so remember point slope form right here should be x1. We should do x minus x1. So I did x minus, and then what I had labeled as x1 was 4. So I took this number and dropped it in the equation right here. Does that answer your question?
Yeah.
Fabulous. Thank you for asking.
And did you divide it by 1 to that?
I divided it by 1 to show you how I'm multiplying fractions.
Okay.
you have a calculator in your hand. But remember, we're prepping for like the TSI, SAT, things that we might need to do arithmetic in our head for. Okay, can we keep going? So you're probably already thinking this, but for both of these equations, we solve for y. And I'm sure you're like, Miss Quigley, that has a name, you just haven't said it yet. I know, it's on the back page. An equation for y, it's now in what's called slope-intercept form. Slope-intercept form is the form of an equation everybody likes the best. I know it. It's y equals mx plus b, where m is the slope, so we still have a slope showing in my equation, and b is your y-intercept value. So it's where the graph would cross the y-axis. Just put a dot right there, which allows us to graph functions pretty easily, because all we need to do to graph a function is know where to begin, the y-intercept, and know how to move, the slope. Begin with a b, and move with an m, right? So if we look at this equation right here, we're going to graph the linear function. I already know that my slope is -3/2, because that is the placement of the m in the equation. What is the y-intercept, though? 2. Now that's where I start. I begin at 2, so I'm going to put a little dot at 2. And I'm going to move and create more points to make sure I'm doing the next slope or the next coordinate point correct. The slope tells me to go down how many?
2.
And to the right how many? So from here, I go down 3 units. 1, 2, 3, and I go over 2. Boom, boom. Put a dot right here. Now, when we're graphing this online on your homework, once you put that second dot, it'll autofill the rest of the line, right? If you've done the orientation assignment, you saw how, bless you, saw how to graph. It's very simple. But since we're doing this by hand, we're not as good as graphing straight lines unless we have multiple points to use. So let's use that slope again. From the new point, can I draw another coordinate point? We will go down 1, 2, 3, and over 2 to put our next coordinate point. And I'll be honest with you guys, I'm horrible at drawing straight lines, so I actually have to do a solid number of points on my graphs to draw a straight line. Just what I know about myself. So we draw a bunch of dots that follow the same slope of down 3 over 2, or to the right 2. And then as good as you can, you're going to draw a straight line through all of those points. You can use a straight edge, you can use the side of your ID, you can use the side of a paper to draw a straight line. Again, online, you will click on the y-intercept, click on one more point with the line building technique, and it will autofill the rest of the line. And the process of graphing slope-intercept form equations doesn't really change from that. Find where you begin, move with the slope. There are 2 special cases of linear equations, though, that are actually way easier to use, and those are horizontal and vertical lines. Now, horizontal lines are going to be lines that go straight across your graph. Since they go straight across, they're always y equal to some number, where that number is your y-intercept. In Algebra 1, you may have heard the acronym HOI. Horizontal lines have 0 slope, and they touch the y-axis, or their equations are y equals. For vertical lines, y'all know the acronym for vertical lines? VUX. Yay, we do remember something. Vertical lines are always x equal to a number, where that number is the x-intercept, because it says x equals. So if we write VUX vertically, vertical lines have undefined slopes, because you're moving nothing, so it's dividing by 0. And they cross the x-axis, or their equations are x equals. So in this next coordinate plane, we're going to graph both y equal to -4 and x equal, I used the whole wrong color for, this is so annoying, but I'm going to fix this. This should have been purple. I know, it's the worst thing that I've ever done. It should be purple. I know, fire me immediately. But like, we already used green somewhere, right? I'm sorry. Don't hate me. I'm so sorry. My human is showing. Okay, so there. We're going to graph these 2 things with these 2 colors. I'm so sorry. Because we're graphing a horizontal line, y equal to -4. Again, I see it starts with a y, so I know this is a HOI equation. I go to -4 on the y-axis. and then I just draw a straight line. What's nice is that because this is a coordinate grid, like you just draw the straight line following the coordinate grid. On your homework, it's still going to make you pick a second coordinate point, I believe, which means you just pick any other coordinate on the same y-axis, horizontal line, and then boom, it will graph it. X equal to 2, if that's an equation, we know that's a Vux equation because of the x. So we go to the x-axis, put a little dot on the 2, and follow that line up and down. Again, your homework, that is not a straight line. You get it, though. Your homework will probably have you pick one more dot, and since it's vertical, just go straight up or straight down to put your second point. The next form of the equation is the least popular form of an equation because it doesn't tell you nearly as much information as the others, and it's called general or standard form of a line. Standard form of a line, yellow, I'm using yellow on purpose. This general form or standard form of a line looks wildly different. If we look at this general form, is there an m in this equation?
No.
Does not tell me any information about the slope. There's no lowercase b to be talking about the y-intercept. In fact, this one just has all of the information on one side of an equation and equal to 0. There's also two more things that mathematically should happen for something to be written in general form. A and B should not be fractions. And generally speaking, A should be positive.
All the time?
Yes. Otherwise, it's not technically standard or general form. And that's going to come in handy in a problem when we're writing things in general form. You have to make sure that A and B are not fractions, and you have to make sure that A is positive. But if we are given general form and asked to do things with it, it's really not that hard to solve the equation for y so that we can then talk about the slope and the y-intercept. Because from this form, from general form, we know nothing about the slope or the y-intercept. So we have to rearrange it so that we do get the correct numbers to talk to us about the slope and the y-intercept. So let's solve for y. We're going to do a few steps all at once. I'm going to leave my equal sign exactly where it is, and I'm going to leave the 2y exactly where it is. But I'm going to pick up and move the 3x and the negative 4 to the other side. So what happens?
Oh, they flip sign?
They flip signs. So positive 3x becomes negative 3x, negative 4 becomes positive 4, right? It's inverse operations. And then we're going to divide everything by 2. So when I do this mathematically, I'm just thinking big divide by 2, and then I split that into 2 small divides. 3 over 2, you can't actually do that without giving me a decimal. Leave it as a fraction, please. But 4 divided by 2 is 2. Now that it's solved for y, it's in slope-intercept form. Slope-intercept form tells me all the information about the slope and the y-intercept. So we can answer the question here, which said, find the slope and the y-intercept for the line whose equation is written there in general form. We would know that the slope is negative 3 over 2, and we would know that the y-intercept is 2. You can't tell me that information until we have it solved for y, until it's written in a form that tells you about the slope and the y-intercept, which general form does not. Now that we've got the 3 forms of a linear equation, point slope, slope intercept, general, you're going to need to make sure you're reading the questions carefully to know what form of an equation it wants your final answer in, because it will be one of those 3. In fact, if we're writing equations, we can also go so far as to write parallel and perpendicular line equations. Some things I'm hoping that we remember or are remembering as I say this is that if we have 2 lines who are parallel, that means that they're going to have the same slope. So the number representing the m spot or the slope should be the same in both equations. It means they're going the same direction, so they're parallel. On the opposite side, if 2 lines are perpendicular, then the product of their slopes is -1, which is not helpful. The helpful way of talking about perpendicular lines is what's bolded. One line is perpendicular to the other if the slope is the opposite reciprocal. Negative reciprocal is another way you might have heard this before. Opposite reciprocals. So if we're writing equations of lines that are parallel and or perpendicular to other lines, say again? Parallel is the ones that go the same direction. Parallel. Perpendicular is the one that meets at a right angle or at a 90-degree angle. Here's a question that might be asked. It says, write an equation of the line passing through the point -3, 1, parallel to the line whose equation is y equal to 2x plus 1. Express the equation in point-slope form and slope-intercept form. So to write point-slope form, we need a point, we need a slope. What's the slope we're going to use? 2. Why 2? It's the coefficient of the x, yes. And because we're writing parallel, we don't change that slope. In fact, just to make sure we know this, I'm going to add a subscript to my m, and it's just going to be 2 lines representing the symbol for parallel. That's not an 11. It's 2 lines representing parallel. Again, to write point slope, I need a point. Do I have a point?
Yes.
Yeah, I have -3, 1. Now all I have to do is plug it into the blue equation from the other side of our notes, which was y minus y1 equal to m times x minus x1. Yeah, here's the first part, right? It said point slope form. Boom, I have point slope form. Slope intercept form is like we did earlier. That means solve for y. So we would do 2 things at once. We distribute the 2 and we add the 1 to both sides so that we end up with slope intercept form 2x plus 7. Again, make sure you're reading questions carefully to see what form I want the equation written in. This time I asked for point slope and slope intercept form. You're always going to use point slope form, by the way. That's the one we start with every time.
How do you remember it?
Point slope form?
Like, yeah, each one.
You just have to memorize them.
Oh.
I hate to tell you that.
So it's a skill issue.
Yeah. You just haven't had to think about these things in a while.
Yeah, I'm not gonna write.
Okay, let's try another one. This one says, write the equation of the line passing through 3, -5 and perpendicular to the line whose equation is x plus 4y minus 8 equal to 0. We're going to express this answer in general form. Whoa. So to write any equation, we always start with point slope, which means we need a point, we need a slope. Do I have a point? Yeah, what's the point?
3 and -5.
What's the slope?
X.
Say what you're thinking, Kennedy. We don't have it. We don't know it for 2 reasons. Number 1, general form does not straight up tell you what the slope is. You have to solve for it. Number 2, we want perpendicular to that line. So what we're going to do is we're going to zoom in for a second on this general form equation. We're going to solve it for y. So if we solve for y, this was 4y equal to -x plus 8. If we divide by 4 everywhere, that's -1/4 x plus 2. What's the slope of that, bless you, general form equation? How did I get that? I divided everything by 4. There's a secret 1 in front of the x, right? So 1 divided by 4. But yes, -1/4 is the slope of that line. But if we think about this problem and I want a perpendicular slope, it'd be 4. Flip it and change the sign. Opposite reciprocals. Opposite means change the sign. Reciprocal means flip the fraction.
So is it perpendicular?
Correct. Flip, flip. Now that I have the point and the slope, it's going back to kind of how we started the other question. We have a point slope equation, so we do y minus y1 equal to m, the perpendicular slope, times x minus x1. This one does not ask for point slope, but we always start there. It asks for it in general form. General form means all of the letters are on the same side and numbers, and it's equal to 0. So to start that off, I definitely need to distribute. This is 4x minus 12. But if I want it to be equal to 0, I'm going to have to move both the y and the 5, which feels weird. So if we move the y and we move the 5, we're going to have negative y and negative 5. Do we follow?
Yes.
All I need to do is write it in the correct form so that it goes x, y, number, which means general form of this equation would be 4x minus 1y minus 17. General form. Say again?
X is always first and the Y is second.
Yes, x is first, y is second, the constant is last, and it can be 0 equals or equal to 0. Now, good question that may have been asked or will come up later is why didn't I subtract this stuff over here? Remember, we want the a value to be positive, and since this was already positive, 4x, I didn't want to move it, because it would make it negative on the other side.
What if it was negative?
Then I would move it to make it positive. So you always want to make the x term positive. That's the side you move everything to, wherever the x would be positive. So let's expand this concept of slope a little bit. And this is where those of you who took AP Pre-Cal will start to have a little PTSD maybe. Slope as rate of change. You've probably heard that phrase before, the rate of change. And in a linear equation, the slope is the rate of change for that function. Slope is the ratio of change in y to a corresponding change in x. So change in y's over change in x's. It describes how fast y is changing with respect to x. It's a ratio. For a linear function, it's the slope because the slope never changed. It's the same straight line all the way across. But we can start thinking about slope as a change in units or a change in data as we expand this to other types of functions. So if we look at this example 3 here, it says, the line graphs for the living arrangements of young adults are shown in the figure on the right. I don't know why it says again. Find the slope of the line segment for the percentage of young adults aged 25 to 34 owning a home and describe what this slope means. So in this graph here, this is a graph representing the living arrangements of U.S. adults aged 25 to 34. In 2000, this is how many owned their home. And in 2017, this is how many owned their own home. In 2000, this is how many lived with their parents. And this is how many lived with their parents in 2017. What we're wanting to know is the slope of the line segment for the percentage of young adults that own a home. So we're going to be using these top coordinate points. All it wants is the slope. We don't change our formula for slope. We're still going to do y2 minus y1 over x2 minus x1. But my coordinate points this time come from the graph. If this is x1, y1, and this is x2, y2, what number should I put first in my slope equation? Wait, sorry, we're not using the live with parents. That's specifically for owning a home. So we're using just these guys. 38.4. What should I subtract from 38.4? 45.4. And what about the denominator? What should that be?
2017. 2000.
Minus 2,000. Okay, cool. This would be a great one for our calculator, unless you notice that these are both 0.4. So what's the difference between 38 and 45? 7. So this is minus 7 on top. And how many years different is that on the bottom? 17. In your calculators, will you please do negative 7 divided by 17? Because we're going to get a decimal answer.
Negative 7 over 17.
What'd you get? Negative 0.41. It doesn't tell us how to round, so we're just going to choose 2. Now this is, again, the percentage of U.S. adults per year that are changing their living arrangements. Now what does this mean? And here's where slope becomes rate of change. If we apply it to the data, what are we actually finding here? And this is a sentence answer. We are finding that the percentage of U.S. young adults aged 25 to 34 who own their own home, that's what the data is telling us. And then we actually look at the number. The percentage has decreased at a rate of approximately 0.41 each year from 2000 to 2017. Since this number is negative, that's why we use the word decreased in our explanation. And we made sure to talk about what the outputs and the inputs are for this function in our explanation. Now, so far, all we've done is find slopes and rates of change with linear functions. What's cool about changing the idea from just slope to rates of change is that we are not stuck just using linear equations each time. When we switch this concept to being called the average rate of change, or, and again, because I teach AP Pre-Cal, the AROC, the average rate of change is what happens when you're finding the rates of change between two data points on a non-linear curve. If the graph of the function is not a straight line, then we start to use, again, average rate of change between any 2 points as the slope of the line containing those 2 points. We're going to force it to be a linear equation, ignoring the rest of the curves of the graph. This line that we've created here is called the secant line. It's a line connecting 2 points. A secant line is always going to be linear. And since a secant line is linear, we can find the slope, the rise over the right, of that secant line. Now, the average rate of change function is the slope function. It's just made fancy. The average rate of change from x1 to x2 on any curve, the slope of this secant line, the rise and the run of the secant line, is found with the formula f of x2 minus f of x1 over x1 minus x2. It's still the outputs divided by the inputs. Changed nothing except for notation. It's still y's over x's. We're still just finding slope, but it's slope of the secant line, ignoring the fact that it's curvy at all. So for example, the figure on the left shows a graph of a particular man's height. So he goes through growth spurts, right? So it's not linear. You don't grow the same amount the whole time. You're a child, so you grow a lot, and then you're like, I don't grow anymore, and then all of a sudden I'm a teenager and I grow a lot, and then kind of grow a little bit more, right? That's kind of how growth works. The question wanted us to find the slope of the secant line containing the age of 13 and 18. So we want to know the average rate of change between age 13 and 18. Clearly, it goes up and then kind of peters back out again, but we're only looking at those 2 points. So we would find the rate of change, aka the slope, where the output was 18, the output was 13 over 18 minus 13. Well, at 18, the output was 76. At 13, the output was 57. So boom, here's my formula that now looks exactly like the slopes we did at the beginning of class today. I do arithmetic. I interpret my answer as the man's average rate of change from age 13 to 18 was 3.8 inches per year. It's just slope. It's just like what we did on the other page. We're ignoring the curves of the graph, pretending like it's a straight line, because it's the secant line between those 2 points. If I take away context and we just do this like a regular looking function, can we do that? Okay, here's a curve. It's a quadratic. It's a classic quadratic. We're going to find the average rate of change of this quadratic from 0 to 1. If we're using my average rate of change formula, and I want to see this average rate of change formula every time written like this, we would do f of the second x minus f of the first x over the second x minus the first x. One note, I'm still using f's here because this function is named f. But if this function was named h, what letter would you put here?
H.
Okay, thank you. Now, we need to know the output when the input is 1. So we look at the graph or the table or the equation that we're given, and we look. Here's 1. What's the output when the input is 1? 1. What's the output when the input is 0? 0. So this is 1 over 0 over 1 over 0, which is just 1. Check.
How do you find the bottom numbers?
Those are just the numbers given, 0 and 1. In which case, so let's see if it makes sense the second time we do it. If we do average rate of change between 1 and 2, this would be f of 2 minus f of 1 over the same numbers from the insides of the parentheses, 2 minus 1. But that numerator is just telling me, find the outputs when the input is 2. So look at my graph for me. What is the output when the input is 2? 4. What is the output when the input is 1? And then we're going to do 2 minus 1. I can't help myself. That's 1, right? Just easier to write it as one number. 4 minus 1 is 3. So then we have 3 over 1, which is 3. We see how this works? Okay. Last one. The average rate of change, again, this time between -2 and 0. So if we're filling out my formula, this is f of 0 minus f of -2 over 0 minus -2. So minus and negatives plus. What's the output when the input is 0? 0. What's the output when the input was -2? 4. Yeah, here's -2. So the output is 4 over 0 plus 2, which is 4. What? 0 plus 2, which is 2. 0 minus 4 is -4. -4 divided by 2 is -2. Now here's what we found. In this first slope of the secant line, it's telling me that the slope should be 1 over 1. Because 1 is the fraction 1 over 1. So if I look between the 2 points, between 0, 0, and 1, comma 1, how much did I have to go up? How much did I have to go over? That's the slope of the secant line. If we connected them together, that's its slope. For the second equation, this would be 3 over 1. So going from 1 to 2, how much did I have to go up? How much did I have to go over? That is the slope of the line connecting those 2 dots, the slope of the secant line. And just to make sure this works the last time, -2 is -2 over 1, yes? So if I'm connecting from -2 to 0, this one's very interesting. The slope is telling me to go down 2 over, wait, no. What am I doing wrong here? Okay, down 2 over 1. But then I do it again, down 2 over 1. I get to the point, yes? Because if I were to draw a straight line between those 2 dots, it would actually hit every single place that I drew those lines. I'm realizing I should have used different colors because this is messy. But do you see how if we connected these 2 dots with a straight line, that has the slope of down 2 over 1, down 2 over 1. That's the slope of the secant line connecting those 2 dots. That's all we're finding with average rate of change. Now, of course, average rate of change is usually going to come with context because a lot of our graphs that are wavy and curvy like that have context, like example 5. It says when a person receives a drug injected into a muscle, the concentration of the drug in the body, measured in milligrams per 100 milliliters, is a function of the time elapsed after the injection measured in hours. The figure on the right shows the graph of such function. That's on the left, but you get it. Where x represents the hours after the injection and f of x is the drug's concentration at time x. Whoa, find the average rate of change in the drug's concentration between 3 and 7 hours. If we're finding this average rate of change, the average rate of change between 3 and 7 hours is just going to be the formula that we practiced up above. The name of this function is still f of x. So I'm still going to use f in my scenario, but I'm doing f of 7 minus f of 3, because those are the hours I care about, right? Between 3 and 7, divided by 7 minus 3. Now we have to look at the graph to find these outputs. What is the output when the input is 7?
0.02.
And what is the output when the input is 3?
0.05.
And then 7 minus 3, that's 4. Can't help myself. Good thing we have a calculator. Can you calculate 0.02 minus 0.05 divided by 4? That's what the top is, and so now divide that by 4. Negatives 0.0075, yes? So let's interpret this back into something that makes sense in this context. We would say that between 3 and 7, the concentration in the bloodstream is decreasing at a rate of 0.0075 milligrams per 100 milliliters per hour. Units are crazy when it comes to medical. The main idea is here, because again, a lot of this is going to be fill in the blank. Why did I use the word decreasing?
Because it's negative.
What's negative?
The final
Yeah, what are we finding? What's it called?
race.
Average rate of change. Okay, and then I go ahead and use this number. The units come from the problem. If you're like, where'd you get all these crazy units? Right here. Milligrams per 100 milliliters, and it's a function of time, so I need to put time at the end. As the end of this video, I'm going to give a little shout out to Lil Aunt Mellow MC Goat 405. Congratulations, guys. You got your shout out.